Hello there and welcome to part 16 of the C tutorial series. In this part we're going to look at function pointers. So we didn't look at these when we covered pointers because there was already quite a lot in the pointers episode. Function pointers are actually very simple. So imagine they essentially just create another name from which you can call an existing function. So say you have a function called add, which takes two arguments, a and b. Right, we won't put the definition there, but assume that this function exists. We can then create a function, we can then create a pointer to that function like this. So we actually essentially just write out the function again, but we put a bracket around the name and we put an asterisk in front of the new name. So say we wanted to create a function pointer called plus, and then we specify the arguments again. And we can then assign to this. So now plus is a pointer to the function add. And this was required, these arguments afterwards and the arguments before, in order to create a type for this parameter. Now that that exists, the following two statements are equivalent. So add 3, 4 and plus 3, 4 are equivalent. They're both going to return 7 if we assume that this function actually adds things together. So it's actually that simple just to create a pointer to an existing function. You just copy the definition of the function, bracketize the name of the function and put an asterisk in front of it, and that gives you a variable of that name to which you can then assign any function which matches that prototype. So that can be useful, but what's more useful is when you typedef a function pointer, because you don't want to keep writing this out every time. Imagine you want to pass a function pointer to another function. You don't want to mess around with this kind of complicated syntax in the definition of your function for your types. So you typedef it. And the very convenient thing is, in order to do that, you just put the word typedef in front of your function pointer declaration. So previously where you were creating a variable called plus and we assigned the address of a function, by putting typedef in front, we now create a new type called plus, which is this function. So plus is a type which returns an int, which is a function which returns an int and takes two integer arguments. Of course, since it's a type, it would be a bit weird to call it plus. Like, we might give it a name like plusfunc. Then what we can do is we can use that type and say plusfunc p equals add. So we're saying that p is a variable that has this type, and then we can call p 3, 4, and that is the same as calling add 3, 4. It's actually pretty simple. Let's look at an example of that, and then we'll do something a little more complicated using function pointers, which is cool. So on the left we've got a file hello.fp.c, and our makefile has one default in it with hello_fp. So the first thing we're going to do is define a function which we can then create a pointer to. So we're going to call it add, and it's going to take two arguments a and b, and it's just going to return the sum of them. So what we're going to do is we're going to say just check that this works, which obviously it will. There you go. Now we'll create a function, a pointer to the function add. So this is actually So what we do is we say, just copy the definition of the function. So it returns an int, but we bracketize the name. We put an asterisk in front of it. We'll call that plus. And again, we need to provide the parameters. By the way, actually, you don't need to provide names in that case, but sometimes it helps to provide names. I'll just show you that you don't need to provide names. So that will then define our variable plus, which has the type that is specified by the return type and the parameters that we've just said. And we can then assign the function add to that. Now plus is just a function that we can now use. Let's run it. And of course, there you go. Plus has the same effect. So, you know, it's a little bit neater, I suppose, to not have the variables there, but sometimes in a function pointer definition like that, you might want to provide the variables if they're descriptive, like, you know, this is the source or the destination, something like that, just because it can help aid understanding. When they're called A and B, it doesn't really help, does it, to include them, so we may as well not bother. But just to show you that you can, it's exactly the same. So then the next step is we can create a new type, which is this function. So we'll get rid of the assignment. We just stick a typedef in front of it, and we'll call it a addition function. Addition func. Does addition func. Right. Then we can create a new variable using that new type called plus, if I can type it, and we can assign the function add. So then let's see if that works. Yeah, it works. So it's actually very straightforward to use a typedef to create a new type which defines a particular function. And of course, the return value has to match the return value, and the parameters have to match the parameters. Being able to typedef functions is really useful. So if we typedef our function, so it returns an int, and we'll give it the name, I don't know, pair function. It takes a pair of arguments, pair f, and it takes two ints. We've now created a type called pairf, whose type, sorry, there's an asterisk there, is a function which takes two integers and returns an integer. We can now use that in another function definition. So say we had a function that performs operations onto integer arrays, and this might be called, I don't know, blend. And it takes an integer array A, an integer array B. We'll assume they're the same length, so let's say it takes a length as well, and they're A and B are the same length, we'll just assume this. And then we can actually take a pair function called f. And then that would allow us, within our function body, to apply our pair function, for example, to each of the elements of A and B pairwise. And then we could, if we wanted to add together the elements of A and B, we could pass in an add function, or if we wanted to subtract A and B, we could pass in a subtraction function. And we can pass in any function which matches that function prototype. So being able to define function types is very useful for then passing them into other functions. A good example of this would be a sort function, where your comparison operation would be different for strings or pixels or cars or people, or to say whether things are equal, greater than or less than, given two objects. And you could then write a custom compare function and pass that in. And that's how, for example, the qsort function works. Alright, let's take a look at that. So we'll begin by creating a typedef, and we'll make it globally scoped. And this is a type of our pair function. So it returns an int. We bracketize the name and put an asterisk in front. So it's a pair function, and it just takes 2 integers. We're now going to define a couple of functions that we can actually use which match that prototype. So we're going to have int add, int a and b, which just returns a plus b. And we're going to have subtraction, which takes 2 integers and subtracts them. And we're going to have multiplication. Now we're going to define a new function, which is not going to do anything because we're just going to print out the answers. And this is a function called blend. So it returns nothing. It takes an integer array A, an integer array B. It takes a length, we'll assume that they're the same, and it takes a pair function called f. I'll just put that on a separate line so that's what's going on. There we go, pair function called f. And all this is going to do is it's going to go through the array, and it's just going to print out the index and the result of the operation. So it's going to print the index, and it's going to call the function f with the 2 arguments. Now in main, we'll obviously need an array of some sort for a and b. So we'll make a an array that has the values 1, 2, 3, 4, 5, and b is going to be an array that has the values, I don't know, 5, 6, 7, 8, 9. And then we can call blend ab, and the length is 5, and we can call it with our function add, for example. And let's have a look what happens. Well, we get 1 plus 5, that's correct, 2 plus 6, and so on. It's added those values together. And of course we can say, we can do that for each of our functions. There you go. And they're behaving as we expect. So it's very useful to be able to define a function type and then use that function type in another function in order to minimize code, essentially. Because what we've done here, instead of having to write 3 separate blend functions, one blend function that does addition, one that does subtraction, and one that does multiplication, we've just written one blend function, and we've passed in the type of function and the type of operation that we want to perform on the 2 arrays. Let me just show you what happens if we try and call blend with the wrong type of function. So say we had a multiplication that takes doubles. Let's see what happens if we try and call blend using this function. Well, we actually just get a warning. So it says that we're passing the wrong function, but it actually allows us to do it. But of course, if we actually try and call this function, we're going to get some bizarre behavior. Let's have a look. So the result from mold is complete garbage, and this is because when mold is called, that function is assumed to be a pair function by the C compiler, and a pair function takes 2 integers. So what it will do, it will pass the parameters as if they were integers, and it will return the result as if, and interpret the result as if it was an integer. But a floating point number is actually going to be returned by the function, and when that's interpreted as an integer, it gives you this garbage result. So it doesn't work. But interestingly, you just get a warning. So you've got to be careful with that one. The last thing I want to look at is, I'm just going to kind of show you something cool that you can do with function pointers. Where, yeah, I'll just kind of show you it. It's going to be an example. Hopefully you think it's cool. For some reason, I think function pointers are cool. I don't know why. There's kind of all kinds of weird things you can do with them. Right, I'll show you that, and then I think we're done. So for the kind of cool thing, what we're going to do is we're going to write a program which then calls whatever function name you pass in and calls with the arguments that you provide. So first of all, we're going to typedef a function type which is going to be called our I don't know, special function or whatever. It returns an integer, and it takes 2 integer arguments, so the same as before. And what we're going to do is we're going to first check the command line arguments. So I'm using this prototype for main. I'm going to say if the argc is not equal to 3, and then we want 4 arguments, right? The function name and the function arguments. And we're just going to print out usage function caller f and then arg1, arg2. And then we exit if we don't have the right number of arguments. If we do, and we're not going to process these arguments properly, if you look at the command line arguments tutorial, you'll see how to do this properly, but we're just going to kind of do this crudely so we don't clutter up the program. So the first argument is going to be our function. And we're going to look this up. So we're going to have a function called getFunction based on the string that's passed. I haven't defined getFunction yet. We're then going to get our 2 arguments, which are integers. And we're going to use a function called atoy, which converts the string to an integer. Again, we didn't use this before in the arguments processing. This is an old deprecated function, but it's useful for just doing things quickly. That will just convert the second argument to an integer, and then our third argument to an integer. Then we're going to call FAB. In fact, what we'll do is we'll print out A, we'll print out B, and then we'll print out FAB, the result. So we've got AB and FAB. So now, of course, we need some functions which actually map this. So we'll just use the same ones as before. We've got add. Just do that on one line, and we've got sub and null. And now we need our function which gets our function. So it returns a special function. It's called getFunction, and it takes a string. And what we're going to do is we are going to create a map of functions to strings. So we're going to create a new typedef, which is a struct, which is going to contain a string. So function name, and it's going to contain a special function, which is, we're just going to call f, and we're going to call this a function pair. or a function. Let's call it a function map type. So that creates a new type, which is a structure of a function name and a special function. Now the beautiful thing is, what we can do is we can now create an array called function map whose type is function map type, and we can put in names and functions like this. So we can do this. So each of these lines is a structure. This is going to initialize 3 structures. So each entry in the function map is one of these structures. Now our get function is going to iterate through. What we'll do is we'll actually just have a define here called num_functions. There's different ways to do this, but we'll have this as 3. By the way, a define, just, I don't know if we've covered them, but it's a macro essentially. It's a substitution, string substitution that's performed before the compilation. So 3 will, wherever num_functions occurs, it will be replaced by 3. And so the length of this array is num_functions. And so we're going to go through all of the functions, and we're going to do a string comparison. And what we're going to do is, if none of them match, we're going to return null. And we're going to say if string comp s with our function map I dot function name equals 0. So if we have a match between our function name and the name that we pass in, then we're going to return the function, which is just called f. And now so we get the function, we iterate through, we get the function. I guess what we should say is if f equals null, we'll say invalid function, and we'll just exit. Otherwise, we're going to print out the name of the function. In fact, what we can do is we'll put a string there, and we'll have a third argument, which will be argv1, which is the name of our function. Okay, let's see if that compiles. It's probably some error, of course. I've probably done something silly. What have I done? Oh yeah, I've put a pointer there. Our special function is a pointer already. It's just, that is the type. That means it encapsulates the fact it's a pointer. We've still got some errors apparently. Called object type special function is not a function or function pointer. Yeah, again, I've done the same thing again. I've forgotten that special function, of course, encapsulates a function, encapsulates a pointer within it. So its type is a pointer. Now there's only one error, expected colon on line 16. Yeah, there's no equals. There we go. We've just got one warning. It's implicitly declaring library function string comp. That's correct. We've got to include string.h for that. There we go. So if we call function caller, we need to obviously provide the arguments. If we provide add12, we call the function add and we get the result. And we can do this for any of the functions which we've defined. So sub or mul. There we go. And of course, if we use a function which doesn't exist, we get invalid function. So I just wanted to show you that you can use, say, a function pointer like that defined in a map like that. And also what I'm showing you here is that within an array, you can kind of nest structures like that. So we're populating structures of those, and each element of this array is one of those structures. Okay, I hope you thought that was cool. I think that's cool for some reason. And yeah, thanks for watching. Alright, well, I hope that was interesting and useful for you. You know about function pointers now, so I'll see you next time.